Code practice time. In this video there are two goals. The first one is to see how to solve this problem, and we are going to put some code here. And the second goal is to see how it should behave in a real interview. So let's get started. So remember, the first step in the real interview is to try to first fully understand the problem. If there is anything you feel unclear, please bring up the question. Don't be shy, and also think about some edge cases at the very beginning you need to take some special care of in the next step. So let's take a look at the question. So longest substring with at most k distinct characters. So given a string and the integer k, return the length of the longest substring of s that contains at most k distinct characters. So take a look at this example, ECEBA. So k as 2 and output as 3. That is because ECE has a length as 3 and it is a longest substring that contains no more than 2 distinct characters. Alright, similarly this one return 1. Okay, it makes sense. So let's see the constraints. It says the input string is never gonna be empty, and the length is smaller than 500k, and the input k could be from 0 to 50. So I would say one edge case I could think about is if k is equal to 0, then you simply return empty. You just simply return 0. That's fine. Yeah, so other than that, I cannot think of any edge case at this moment. So after we figure out everything from the first step, the next step for us to do is to find a solution. So here we talk about the solution to the interviewer, do some back and forth communication, get an agreement on the approach, and do some runtime space analysis. And then after an agreement, we should be good to go for coding. So let's see how to solve this problem. So for this kind of string problem, there is a pretty common technique for a string problem, which is called sliding window. So what is a sliding window? So suppose, let's say I use this dash, this to represent the input string, and the sliding window is something like so there could be different kinds of sliding window. So for example, it could be fixed length sliding window. So like for example, if it has fixed size as 3, then it is a fixed sliding window that keeps moving towards the end of the string. Otherwise, there could be some flexible sliding window, like the length of the sliding window can change. But anyway, the sliding window technique used in the string problem, it has some common characteristics. So first one, the sliding window is always moving towards the end, so it is never going back, no backtracking. And the second characteristic is, during the time you move the sliding window, you have a certain condition to decide whether to move the left pointer or whether to move the right pointer. And at the same time, you need to keep some kind of the statistics within the substring managed by the sliding window. So the statistics really depends on what the question asks you. But overall, that's about the two characteristics about a sliding window. So first of all, always move towards the end. Second one, keep some statistics about the substring within the sliding window, and make use of it to move the sliding window around. And so that's it about the general sliding window description. So let's see how to use this approach in this question. So for this one, you keep a sliding window. Let's suppose the input, let's just use this example. So we have a sliding window managed by the left pointer and the right pointer, and at the same time we will keep a map. So the map, the key of the map is going to be the character, and and the value is going to be the frequency of the character within the sliding window. So first we try to move our right pointer until the side, and we keep updating the map, the frequency map, until the size of the map become larger than k. If it is larger than k, then it means, so for example, when we move here, we have 3 keys, E, C, and B within this car free map. If it moves out of, if it has more than k distinct characters, then it is time for us to actually move the left pointer to exclude at least one distinct character from the map. So in here, we just keep moving the left until we say that one character within the hash map, within the frequency map, has frequency at 0, which means we have excluded one character from the sliding window. So that's essentially how we move our left and right pointer and what the statistics we are keeping track of. And also one important thing is that we also keep track of another thing, which is a maximum valid substring. So but we can get there in the coding part. So overall, the runtime for this approach is going to be linear to the input string, to the length of the input string, to be exact. So so the third part is about coding. So for coding, don't be too slow, and also think about the correctness and also the readability of the code. So let's take a look at the coding part. First of all, as we said, if k is equal to a 0, if a k is equal to 0, then we just need to return 0. So otherwise, we will have a map of the character to character integer car, let's say car free map, new hash map. Then we are going to have the max length, let's say as equal to 0. So we are going to say for int I is equal, so let's say r is equal to 0, r is smaller than s dot length, the plus plus r. So every time we will put car free map dot put so s dot car at r and car free map dot get or default as I think we can just car right car as equal to s dot car at r. Yeah, so that we don't need to call API twice. So this is going to be put this one 0 and plus 1. So if the size, so if the car free map dot no, so okay, so while the car free map dot size is larger than k, then it means we have more distinct characters within the car free map. So now what we are going to do is we should try to move our left pointer. So actually we need to have a left pointer at the very beginning here. So so car free map dot put, so first of all you need to get the right car, sorry, the left car. So left car is equal to s dot car at l. So car free map dot put left car car free map dot get left car 0 get or default. So actually don't need to call get or default because it is for sure to exist in the car free map. So -1. So if the car free map dot get left car is equal to a 0, then we can simply remove it from the car free map. Remove the left car, and we need to plus a left plus L. Alright, so at the end it is for sure that we have a valid string, substring. So if I would say if it's like max length is equal to max length, what's that, right? Sorry, this should be right minus left. So if it is equal to 0, then we just remove it. Okay, so r minus L, we need to plus 1. Yes, so that's essentially it, and then finally we are going to return the max length. So let's so after we are done with coding, it's not done. We still need to do some testing. So for testing, so usually you need to go through a simple example to explain how this piece of code is gonna work, and at the same time do some sanity check about the logic. And after that, you will need to come up with some different test cases to indicate about test coverage. So let's take a look at this example, and the k is equal to 2. So at the beginning, car free map is empty, and then max length is equal to 0, and also L is equal to a 0. So when r is equal to 0, we are going to have car free map as E1, and then the size is equal to 1, which is smaller than 2. So you just keep moving, and we have r is equal to 1. Then we have the C, if you have extra C1, then r is equal to 2, then E2 C1, and then r is equal to 3. Oh, at the same time, I think I forgot to update the max length. So at the same time, you need to update the max length to be r is equal to 2, the max length is equal to 3. Alright, so when r is equal to 0, 1, 2, 3, then we have the map something like E2C1 B1. So it's time for us to move the left pointer. So left pointer currently pointing to E. So we are going to have put E1 and plus L. And then we are going to put C0, and since C has frequency at 0, then we are going to remove it from the car free map, and then we have LS2. So currently the length is 2, which is still smaller than max length. Then we are going to move our right pointer on. So next time the right pointer is equal to 0, 1, 2, 3, 4. It's equal to a 4. Then we have an extra A in it. So similarly, we are going to move our left pointer to make sure that we exclude the E from the map. So overall, I think it works fine. Let's give it a shot. Okay, so it's good. Let's give it a submission. Alright, so everything looks good. So I would say regarding the test case setup, definitely set up something like the edge case when k is equal to 0, and also set up some cases like input example 1 Yeah, so then that should be it. Yeah, then I think it should be able to cover all the branches within this piece of code. Yeah, so that's it for this coding interview. So if you have any in this coding question, so if you have any question about this coding puzzle or about the solution, feel free to leave some comments below. And if you like this video, please help subscribe to this channel, and I'll see you next time. Thanks for watching.